most of the students end up overthinking this integral because they don't even know the first step. In order to integrate this, remember that this is a square root of a linear function times a linear function. Whenever you see a function within a function, so it's a square root, and inside of that square root there is a linear function. Whenever you see function within a function, the inner function is what you have to put as u in most cases. If you want to see the detailed video of how to decide u in u substitution, check out the video that is attached on the top right now. Okay, but in this case the inner function is x plus 2, so I can just put x plus 2 is equal to u. Okay, now what I have to do is convert that entire integral from the x world to the u world. In order to convert that integral from x world to the u world, I'll also convert that dx in terms of du. So in order to convert that dx in terms of du, I'll have to differentiate both the sides with respect to x. Okay, so let's differentiate. So derivative of x with respect to x is 1, plus derivative of 2 with respect to x is 0. Derivative of u with respect to x is nothing but du by dx. Okay, so I differentiate both the sides with respect to x. 1 plus 0 is nothing but 1, and this is du by dx. Okay, since du by dx is 1, I can just say that du is nothing but dx. So both are nothing but equal. So I can just replace that dx with just du. I hope that makes sense. Now we need to convert that entire integral in terms of u. So in order to convert that integral in terms of u, I'll also have to find the value of x. So from here, I can say that x is nothing but u minus 2. Subtract u on both the sides, or just shift that 2 on the right hand side. Now let's convert that entire integral in terms of u. So that will become integral of, so x is going to become u minus 2, and I have square root of x plus 2 is nothing but u, and that dx is nothing but du. So I convert that entire integral from the x world to the u world. Now what you can do, just multiply that square root of u inside of that linear term. So you have u square root of u, okay, minus 2 square root of u with respect to u. I hope that makes sense so far. We can use the law of exponents here. This is nothing but u to the power 1, and the square root of u is nothing but u to the power half. Now because the base is same, we can add up those powers. So this will become integral of u to the power 1 plus 1 by 2 is nothing but 3 by 2 minus 2 u times, or sorry, u to the power 1 by 2, because that square root can be written as power 1 by 2 with respect to u. Now let's give that integral to both of those terms. So this will become integral of u to the power 3 by 2 with respect to u minus 2 integral of u to the power 1 by 2 with respect to u. Because that 2 is constant, I just took it out of the integral. I hope that makes sense. Now that integral u to the power 3 by 2 is nothing but u to the power 5 by 2 divided by 5 by 2. Okay, I add the power by 1 and divide by the same power by the basic algebraic formula of integral, minus 2, and this u to the power half integral is u to the power 3 by 2 divide by 3 by 2, and plus let's add the constant of integration c. Now let's convert this final result back in the x world. So u was nothing but x plus 2. So what we can, instead of u, we can just write x plus 2 to the power 5 by 2. Remember that this 2 is in denominators. Denominator can be taken in the numerator. So I have 2 divided by 5. Okay, so that 2 just came in the numerator. Okay, and I already have that 5 minus this 2 again can be taken in the numerator. So that will become 4. And instead of u, I can just write x plus 2 to the power 3 by 2 divided by, I have 3 already, plus the constant of integration c, and this is nothing but your final result. I hope that makes sense. If you understand the concept that I'm teaching, you can request you to like this video and subscribe this channel. It is free for you, but it motivates me to create more such helpful content. Also, if you are struggling with trigonometric integrals, you can see the link right here.